are going to work through some proof practice, but we are going to start with some Uno cards. And if you haven't played Uno in a while or you just don't know the rules, here's what you need to know for today. You can play a card that either matches in color, number, or if you play a wild card. So that's what you need to know. You need to be able to match color, number, or play a wild. So we are starting, someone has played a blue 5. That is where we are starting, right here with our given. And we are going to use the 4 cards we have in our hand so that we are able to play our last card, a green 9. So hopefully you're looking at this, and if you're familiar with Uno, I think you'll be able to do this pretty quickly. But I am going to go through the order that I'm going to play my cards, and I have to use all of them. Okay, so my first play is to play the blue 3. After the blue 3, I can then play my red 3. From my red 3, I can play the red 4, which then lets me switch to the green 4 so that my last card can be a green 9. So hopefully you watched our properties from algebra notes video already and you know what's coming next. I'm going to ask you to justify each of our steps. And what we're looking at are what are the rules that let me play each of my cards. For example, I can play the blue 3 on my first card, that blue 5, because they match in color. Then I can play the red 3 because of having the same number. Then I'm matching color again. Then I match the number. And my last one, I match the color. So the same reason you follow the rules in Uno are all the things we're doing with geometry proofs. We're just following the rules. Because if someone played a yellow 2 in the middle of this hand, you would say, you can't do that. Here are the rules. And that's what I'm doing with you in math class this year is what are the rules? We're playing by the rules. Okay. So here's your Uno example. I want you to decide what order you're playing your cards in. So my first card would have to be the green 8 because that's the only one out of my 3 options that matches in color or number. From my green 8, I can play the green 1, and then that'll allow me to switch to yellow by matching the numbers so that I can play my yellow 3. There's another practice. If you want it, you can pause the video and go through what order you would play your cards. I would go blue 0, number 1, because it matches in number. Then I'm switching to my blue 9, which sets me up for a green 9, followed by a green 6, which I can then play my red 6 on because they match in number. Now I'm going to switch it up here a little bit because I'm giving you a red 2. I want to get to a green 8, but I want to do this in the shortest possible moves. So I want to use as few cards as necessary. So look at our options and decide how you would do this proof. I think this can be done in one step. All I need to play is the green 2. Because if I play the green 2, it matches in number here and sets me up with the correct color to play the green 8. Opposite of what we just did, I want you to use all of the cards given in your hand here to get from the red 2 to the blue 5. Because none of my number or color cards match, my first play is the wild card. And the wild card allows me to change the color of what I'm playing. And remember, I have to use all of my cards. So I'm going to change my color to green, and then I'm going to play the green 4, the green 8, followed by the blue 8. And the blue 8 matches in color of my blue 5. So make sure when you thought about this, you played all 4 cards. My next question, which cards given below do not need to be used in this proof? How can we go from a blue 0 to a yellow 7? And I can do this just using these 2 red cards. So I'm going to use my red 0 to switch colors, and then a red 7 to set it up to match a number. All right, I'm going to jump ahead to this one. Given a blue 0, prove a red 5. So get from here to here. But I want you to try to prove it in 2 separate ways. Okay. So my first idea is that I will play the green 0 followed by the green 5. And I can do that in 2 steps. I could also play the wild, and I'm going to change the color to yellow, which will then allow me to play the yellow 5 so I can get to a red 5. And the reason I wanted you to do this 2 different ways is so that you can see there's different ways to solve or prove all of our rules. There's different ways to play. So when we are checking proofs in class, make sure you ask questions, because one way to do it is not always the only way to do it. As promised, here are all the things we're allowed to use as a justification in a proof. So in Uno, your reasons are always the rules from the rule book. In geometry, you've got 4 things you can use as your justifications. The given information, so whatever you're starting with, definitions, postulates or properties, so all the properties from algebra are things we can use, and any theorems that we've already proven. So you'll hear me talk about our toolbox a lot. Remember, we're building our house. We were gathering all of our tools in chapter 1 with all of our vocab. Now we also have some postulates. We have the angle addition postulate and the segment addition postulate, and those are going to be some frequently used tools as we go through our work here. And what we're going to do now is actually prove a theorem. So I want you to copy this theorem down, the midpoint theorem. The midpoint theorem says that if M is the midpoint of AB, then the segment AM is equal to half of AB, and the segment MB is equal to half of AB. Now, before I start, I'm going to give myself a picture to look at so I know what I'm talking about. So I've got my segment AB, and I know M is the midpoint. So now I can actually see the figure that I'm talking about. So my given information here is that M is the midpoint of my segment AB. So that's given. And now I'm trying to figure out how can I go from knowing just the midpoint to justifying that each of the segments is half of the total. If I think about setting it up as an equation, then I'm probably going to use my segment addition postulate. And that's what I'm going to do as my second step. I'm going to say AM plus MB equals the total segment AB. And again, that's my segment addition postulate. Now I'm going to call on the definition of a midpoint, which tells me that a midpoint creates congruent segments. So I'm going to say that AM equals MB. And what doing that allows me to do is make a switch in my equation. So I'm going to take out one value of MB, and I am going to replace it with another value of AM. So now my equation will be AM plus AM equals AB. And this was a use of our substitution property. I want to clean up my equation because I have 2AM equals AB. And I don't need a justification here. I haven't changed anything. I just kind of simplified and cleaned up. So if you're keeping track of our steps, they look like this. But my next step will be that AM equals half of AB because of my division property. So if I divide by 2 on both sides, that's what's going to get me to half of the total segment. And my last one, remember, I need to prove both of these segments are half of the total. So my last step is going to include that MB equals half of AB. And I am again going to use my substitution property because you're literally switching two things in an equation that you know are equal to each other. So my last step is substitution. Our second theorem we're going to prove is the angle bisector theorem. So copy this one down and try to do the proof start to finish on your own. I will give you a hint. An angle bisector works very similar to a segment midpoint. So your proof might be pretty similar to how we worked through the proof of the midpoint theorem. So give it a try. We'll talk about these in class. Don't be stressed, and we'll check in together when we're back in class.